replacing labeled real image datasets with auto-generated contours. The performance of formula-driven supervised learning can match or even exceed that of ImageNet 21K without the use of real images, human and self-supervision during the pre-training of vision transformers. To understand the performance of the synthetic images in FDSL, we tested two hypotheses, namely, Hypothesis 1, object contours are what matter in FDSL datasets, and Hypothesis 2, task difficulty matters in FDSL pre-training. From the attention map on FractalDB, where attention is focused on the outer contours, this suggests that the contour-based image representation must be effective in FDSL, therefore we construct radial contour DB, RCDB, in the paper. The proposed radial contour is an object made by superimposing polygons. Here, we illustrate the visual presentation how to draw the radial contour database. At the beginning, we define the radius and number of vertices in a radial contour image. Then, we shift vertices in order to draw multiple polygons in an image. The processing is iteratively executed. The vertices are connected under the framework of Perlin noise. We render the radial contours in the number of polygons. We consider the image translation in an object contour at x, y axis. Next we consider the hypothesis 2. We hypothesize that the accuracy of FDSL can be improved by adjusting its parameters to increase the difficulty of the pre-training task. FractalDB has been augmented with 3D IFS as XFractalDB, and RCDB was increased their parameters in order to construct the FDSL dataset. Regarding Hypothesis 1, we confirm that image representation using object contours tends to yield higher scores. RCDB and FractalDB give the highest accuracy. Regarding Hypothesis 2, we confirm that more difficult tasks improved the accuracy of RCDB and FractalDB, here, XFractalDB. In point-rendered FractalDB, although the fractal images with 50K points trained the visual representations, the fractal images with 10K points failed. At the same time, the RCDB with broken contours failed to acquire a visual representation. The attention and accuracy were also broken from the visualization and result. See Section 4.3, Discussion of Hypotheses 1 and 2 in these points. Pre-training with XFractalDB 21K, RCDB 21K outperformed that with ImageNet 21K. This shows that we can match the accuracy of pre-training on ImageNet 21K with synthetic datasets in FDSL. In COCO detection and segmentation, our pre-trained model achieved scores similar to those for the model pre-trained with ImageNet 1K. In comparison to SSL, XFractalDB 1K with 1.4K instances achieved a higher average accuracy than that of the self-supervised PASS dataset. PASS and FDSL both attempt to improve ethics in datasets. Moreover, FDSL pre-training partially outperformed ImageNet 1K pre-training in cars and flowers with XFractalDB. In this paper, one of our major findings is that we can surpass the accuracy of a bit pre-trained on ImageNet 21K using our FDSL datasets. We believe that further improvements in contour shapes and a more complex classification task are possible, which leaves open the possibility to scale up the pre-training on synthetic datasets to one day outperform huge-scale datasets. We believe that formula supervision on synthetic images is a broad area of research at a similar granularity as self-supervised learning. Moreover, as our previous researches, the FDSL framework can be extended in broader areas. We would like to assign the pre-trained models with FDSL to general training, just like the ImageNet pre-training has become the basis for general tasks. Thank you for listening.